So, this is our Chapter 9 Quadratic Functions Part 1 review. If I was you, I would make sure that you're copying everything that you have here down as we go. Okay? And this will be on Canvas, the recording, so you can always go on there. So, there will be 3 questions on the Intro to Quadratic Notes. So, you can go back to your Intro to Quadratic Notes. There will be 3 questions that go along with that. This has 100% to do with characteristics. Okay? So this one's asking you to name 3 things described in the graph. Y equals negative 2x squared plus x minus 6. So remember, when we're describing, we're looking at the A and the C. Okay? So our A is negative, so it opens down. If A was positive, it would open up. Remember, the absolute value of A is what tells you if it's narrow, wide, or average. So the absolute value of negative 2 is 2. So that is greater than 1, so it is narrow. And then our 6 is our y-intercept. So our y-intercept is 0, negative 6, and then it has a maximum point. Okay? That's also told by the A because it opens down, so it's going to have a maximum point. Your maximum point is always your vertex. Okay? So, maybe some things to remember that this is why I had white. The absolute value of A, if that is equal to 1, then it is average. If the absolute value of A is greater than 1, then it is narrow. And if the absolute value of A is less than 1, then it is wide. Okay? So this one's asking us to order from widest to narrowest. And it gives us 3 equations. So our first equation has a 1 for A, so this would be average. This would be the absolute value of negative 4, so 4. So 4 is greater than 1, so it's narrow. And then 1/2 would be wide. So the order would be y equals 1/2 x squared, y equals x squared, and then y equals negative 4x squared. But I would make sure that you look back at your notes for these and have these notes. There's 2 graphs, 2 charts for them. Okay? So then you do today's notes. Up front, right there, you should write them. You can take them and then you can go over everything later. Alright, there will be 5 questions about standard form graphing, okay, and we have notes about standard form graphing. So 2 in which you're finding the vertex and axis of symmetry, 3 where you will be graphing the parabola. So for example, this one's asking us to find the axis of symmetry for y equals negative 2x squared minus 4x plus 5. So the first thing that we have to do is find our vertex, which we have to find our axis of symmetry. So axis of symmetry equals negative b over 2a. So negative b, negative 4, over 2 times negative 2. So my axis of symmetry would be x equals what? Negative 1, because this would become 4, and this becomes negative 4. -1. So then I'm going to substitute my value from x into my original equation and solve for y. So y equals -2 times -1 squared minus 4 times -1 plus 5. So our y would equal 7. So my vertex would be -1, 7. So my vertex is -1, 7, and my axis of symmetry is x equals -1. Remember, you have to provide the x equals. If you do not, then you'll get it incorrect. So there will be 3 questions about graphing. So in order to graph, we have to do the same thing. So I have to find my axis of symmetry. I have to find my vertex, and then I have to find an additional point. Okay? So I'm going to take my equation, and I'm going to find my axis of symmetry. So, -b over 2a, or x equals. So, my b is what? Here. Is there an x by itself? No x. So 0 over 2 times 1. So that would be 0. Okay, then I'm going to substitute that back into my equation to find my y for my vertex. So y equals 0 squared plus 1. So y equals 1. So my vertex is at 1, or 0, 1. Okay, can I use my c as my additional point here? No, because my c is my vertex. Okay, so I have to find an additional point. I'm going to pick something near 0, so 1, okay, or -1. We could use either one. You want to do just one away. So 1, when x equals 1, so I'm going to substitute 1 in. Y equals 1 squared plus 1. So y would equal 2. So my additional point would be 1, 2. And I'm going to be able to mirror this across my x-axis. So my graph, or my axis of symmetry.
Which
yes.
is the y.
It's the y-axis, yes. So I would graph my axis of symmetry first, which is my y-axis. Then, or my y, yeah. Then I would graph my vertex, which was at 0, 1. My additional point, which was at 2, or 1, 2. And then I can mirror that point over my axis of symmetry. And then draw my graph. Yes.
When we're graphing those 2 points, the 2, 5, and -2, 5,
Those are just additional points. You don't have to. No, you just need one additional point so that you can draw the shape. Okay. The only time you need additional points is if you are trying to find your intercepts, your roots. All right. From intercept form and vertex form, we're going to have 5 questions. 3 on vertex form and 2 on intercept form. So this one's asking us to graph the equation. Okay, so we have to, first, it's in vertex form. So what is my vertex? Is my H and K. So remember that this would be y equals a times x minus h squared plus k. So my h is going to be 1.
-1.
No,
Oh, just 1.
just
Oh,
1
yeah,
because my equation's negative. Remember, it's the opposite sign. And my k is -4. So my vertex is going to be 1, -4. What is my axis of symmetry? X equals 1. Okay, now I need to find an additional point. Okay, so I'm going to want to find something that's near 1. So I can do like 2 or 0. 0 is usually easier to do. So our additional point when x equals 0, so we're going to substitute 0 into our equation. So we're going to have y equals 0 plus 1, or minus 1, I'm sorry. Minus 1 squared minus 4. So our y would equal 1. No. This would be 1 minus, or not 1. Let me get the wrong question. 7, sorry. So y equals 1 minus 4, so that would equal -3. So my additional point would be 0, -3. So when graphing this, I would graph my vertex, my additional point, and mirror that point over, okay, and then draw my graph. Okay, from intercept form, so an intercept form, it says identify the vertex. So we have to set both of our binomials equal to 0 to find our intercepts. So I'm going to have x minus 3 equals 0 and x plus 5 equals 0. So my x-intercepts are x equals 3 and x equals -5. So my x-intercepts are 3 and -5. So from there, I can find my axis of symmetry that's halfway in between these two. So I'm going to have 3 minus 5 over 2. We're going to divide it in half. So 3 minus 5 is -2 over 2. So my axis of symmetry is x equals -1. Okay? Then I'm going to substitute in -1 into my equation to find the y. So y equals 2 times -1 minus 3 times -1 plus 5. So we'll get 2 times -4 and times 4. So y would equal -32. So our vertex would be -1, -32. If they want us to graph from intercept form, then we already have our x and y intercepts. We just need to find our vertex, and those are our 3 points. So our x-intercepts are what on this equation? -3 and 1, yeah. So then I can find my axis of symmetry by doing -3 plus 1 divided by 2. So my axis of symmetry is x equals, what does x equal?
-3 over 2.
What's negative 3 plus 1?
Oh, -1.
So negative 1. Okay, so now I'm going to substitute negative 1 into my equation to find the y. So y equals negative 1 plus 3 and negative 1 minus 1. So y would equal 2 times negative 2. So y would equal negative 4. So my vertex is negative 1, negative 4. So I can just graph my intercepts and my vertex. So my intercepts here are at negative 3 and 1. My axis of symmetry is at negative 1. My vertex is right here at negative 1, negative 4. And then my additional point that I found was at negative 1, or I'm sorry, I don't need additional points because I already have my vertexes. I can just draw my graph. Okay? So solving by graphing. So there will be 2 questions on solving quadratics by graphing. One on already graphed and one that requires graphing. So what are we looking for when we are solving quadratics? What am I trying to find? My roots, my zeros, what are those? What are my answers for when I'm solving?
Your x-intercepts.
My x-intercepts. So I'm trying to find the x-intercepts. And what is my y for my x-intercepts? What's the y value? 0. So that's why the equation will be set up to equal 0. So I'm looking for, and these could be zeros or roots. That's what they can call them. So if you're solving by graphing, you're going to have to graph the equation the same way that we have been doing, where you find the axis of symmetry and the vertex and an additional point. Okay, and where it crosses your x-axis, that's going to be your answer. So what would be my answer for this one? Where does it cross the x-axis?
No.
It doesn't, so it would be no solution. Okay, we are going to have 5 questions on writing quadratics. 3 in vertex form, 1 in intercept form, and 1 in standard form. Okay? So this one says to write the equation of a parabola with a vertex at 2, -9 through the point 0, -5. So this is going to be vertex form because it's a vertex. We give you the vertex and a point. So to solve that, we will have our equation, which is y equals a x minus h squared plus k. So I'm going to substitute the information that I know. My y value is going to be -5. My a, I do not know what my a is. My x is going to be 0. My h is going to be -2 squared, and my k is -9. So I'm going to solve for A. Thank you. You're welcome.
There's just 3, 2 of them left.
Okay. So A equals 1. Then I'm going to take my A and my vertex and substitute it back into my equation. So I'm going to have y equals 1 times x minus 2 squared minus 9. Do I need this 1 out front? No. So my final answer is going to be y equals x minus 2 squared minus 9. And that's my answer. Okay. So, continuing that. So it says to write an equation of the graph in intercept form. So this was asking for intercept form. So I'm going to look at my intercepts. And an additional point, I recommend you using the vertex. So my x-intercepts are 3 and 5. And my additional point, I'm going to use my vertex, which is 4, negative 1. Okay? Then I'm going to take my equation, y equals a, parentheses, x minus p, and x minus q, and I'm going to substitute the information that I know. So y is negative 1. I don't know what a is. I'm looking for a. I'm going to have x minus 3, and or not x. 4 minus 3, and 4 minus 5. So I will get negative 1 equals a times 1 times negative 1. So negative 1 equals negative a, so a equals 1. Okay, then I'm going to substitute this information back into my equation. So I will get y equals 1 times x minus 3 and x minus 5. Do I need the 1 out front? No. So then it just becomes this. When we're going from into standard form, you have to solve it first in a different form. So if they give you the vertex, you're going to be putting in vertex form first, and then going into standard form. If they give you the intercepts, then you're going to go from intercept form into standard form. So this one, they give me my vertex, so I have to go from vertex form into standard form. So vertex form is y equals a times x minus h squared plus k. So I'm going to have 5 equals a negative 1 plus 2 squared minus or plus 3. Okay, and I'm going to solve for a. So my a is going to equal 2. Then I'm going to take my 2 and my vertex and substitute it back into my equation. Okay, so I will have y equals 2 times x plus 2 squared plus 3. Okay, whenever you have a binomial and you square it, it's times itself. So we can use our special method. So I square the first term, so that becomes x squared. I square the last term, 4. My middle term, remember, it's the product of the two doubled. So 2x doubled would be 4x. So this would be plus 4x plus 4. Okay, and then I have this 2 out front plus 3. So now I'm going to multiply my 3, or my 2. So this becomes 2x squared plus 8x plus 8. Then we have plus 3. And then we combine like terms, so 8 plus 3 is What's 8 plus 3? 11. So that is my answer. So there is actually only going to be 20 questions and 5 challenge questions on this test. And we have a test review that you can use.